Hello trainees. Welcome to today's class of week number 36. In week number 36, we are going to discuss about the topics of 1. Screw thread. 2. Principle of cutting screw thread. 3. Principle of chasing screw thread. And 4. Setting tool for cutting internal and external threads. In today's class, we are going to discuss about the topic of principle of chasing screw thread. Let's see the objectives of this topic. You shall be able to state the necessity of a thread chasing dial. State the constructional details of a British thread chasing dial. State the functional features of a British thread chasing dial. First, we are going to see introduction of thread chasing dial. To catch the thread quickly and to save manual labor, use of a chasing dial is very common during thread cutting by a single point cutting tool. A thread chasing dial is an accessory. Let's see the constructional details of thread chasing dial. The figure shows constructional details of a British thread chasing dial. It consists of a vertical shaft with a worm wheel made out of brass or bronze attached to the shaft at the bottom. On the top, it has a graduated dial. The shaft is carried on a bracket in bearing bush, which is fixed to the carriage. The worm wheel can be brought into an engaged or disengaged position with the lead screw as needed. When the lead screw rotates, it drives the worm wheel, which causes the dial to rotate. The movement of the dial is with reference to the fixed mark or index line. The face of the dial is usually graduated into 8 divisions, having 4 numbered main divisions and 4 unnumbered subdivisions in between. The number of teeth on the worm gear is the product of the number of threads per inch on the lead screw and the number of numbered divisions on the dial. The half nut can be engaged 8 times for 1 revolution of the graduated dial. The movement of the carriage for 1 complete revolution of the dial is 4. Since the dial is having totally 8 graduations marked, each graduation represents a half travel of the carriage. And next, we are going to see some examples of thread chasing dial in chart. The first example. Thread per inch to be cut is 8. The ratio is equal to driver by driven is equal to thread per inch on lead screw by thread per inch to be cut is equal to 4 by 8 is 1 by 2. The predetermined travel of a quarter inch is represented by the dial position in the exact middle between any numbered division and adjacent unnumbered division. The half nut engagement can be done at any position at which it can be engaged. That is 16 positions. The second example. Thread per inch to be cut is 6. The ratio is equal to driver by driven is equal to thread per inch on lead screw by thread per inch to be cut is equal to 4 by 6 is 2 by 3. The predetermined travel of half inch is represented by dial movement from any numbered division to the next adjacent unnumbered division. The half nut can be engaged when any numbered or unnumbered graduation coincides with the 0 line, 8 positions. Third example. Thread per inch to be cut is 5. The ratio is equal to driver by driven is equal to thread per inch on lead screw by thread per inch to be cut is equal to 4 by 5. The predetermined travel of 1 inch is represented by the dial movement from any numbered division to the next numbered division, or from any unnumbered division to the next unnumbered division. Therefore, if the first cut is taken when a numbered division of the dial coincides with 0, then the half nut engagement for successive cuts can be done. When any numbered division coincides with the 0 mark. If the first cut is taken when an unnumbered division coincides with the 0, then the half nut for successive cuts is engaged when any unnumbered division coincides with the 0. 4 positions. The fourth example. Thread per inch to be cut is 3.5. The ratio is equal to driver by driven is equal to thread per inch on lead screw by thread per inch to be cut is equal to 4 by 3.5 is 8 by 7, and predetermined travel is 2 inch. The half nut can be engaged only at opposite numbered or unnumbered graduations, 2 positions. The fifth example. Thread per inch to be cut is 2 of 3 by 4. The ratio is equal to driver by driven is equal to thread per inch on lead screw by thread per inch to be cut is equal to 4 by 2 of 3 by 4 is 16 by 11. And the predetermined travel is 4 inch. The half nut can be engaged to catch the thread only when the same numbered or unnumbered graduated line at which the first cut is taken coincides with the 0 line, 1 position only. Sixth example is thread per inch to be cut is 1 of 3 by 8. The ratio is equal to driver by driven is equal to thread per inch on lead screw by thread per inch to be cut is equal to 4 by 1 of 3 by 8 is 32 by 11. And the predetermined travel is 4 inch. The half nut engaged for the first cut should remain at the engaged position till thread cutting is completed, and the machine is reversed as it takes a long time to cover the predetermined travel arrived at by calculation. And last, we are going to discuss about the definition of center gauge. Center gauges and fishtail gauges are gauges used in lathe work for checking the angles when grinding the profiles of single point screw cutting tool bits and centers. In the image, the gauge on the left is called a fishtail gauge or center gauge, and the one on the right is another style of center gauge. These gauges are most commonly used when hand grinding threading tool bits on a bench grinder, although they may be used with tool and cutter grinders. When the tool bit has been ground to the correct angle, they may then be used to set the tool perpendicular to the workpiece. They can incorporate a range of sizes and types on the one gauge, the two most common being metric or UNS at 600 and BSW at 550. Gauges also exist for the Acme thread form. To boost your brain power, we are going to play one quiz related to this topic. The question is, what is the name of the part marked as X? The options are A. Shaft, B. Bracket, C. Lead screw, and D. Worm gear. Yes, you are right. The answer is C. Lead screw. With this, we are completed the topic in part 3 of week 36. I will be back with the remaining topics in the next videos. Thank you.